Hey, how are we doing? First video of the new year. Just been super slammed with tutor sessions and stuff like that. Hope you understand. User Kim Park, about a week ago, requested this problem, the 2010 AMC 10A problem 25. Feel free to make problem requests in the comments. I've got a backlog of about 10 questions right now. I will get to them as soon as I can. I may lose some. I need to create some kind of a document, like a Google Doc that's editable. But maybe with some rules, like you can make one request a week or something like that so that one person doesn't dominate the requests. I also have a website will be coming out soon and I will have that feature on there, but I don't know how soon, might be a month. There's also, if you can go to the community tab and read my most recent post, it's just about the commenting and how long it takes me to respond. I do try to respond to every substantive comment. Please read that. It sometimes will take me a little while, especially right now, right before the tests. Let's get started. The 2010 AMC 10A problem number 25. Jim starts with a positive integer n and creates a sequence of numbers. Each successive number is obtained by subtracting the largest possible integer square less than or equal to the current number. So it has to be less than or equal to until 0 is reached. For example, so instead of us making our own, they're going to give us one. How kind. For example, if Jim starts with n equals 55, this number here, then his sequence contains 5 numbers. It will look like this. Start with 55, subtract 7 squared, which is 49. That's the largest square less than or equal to 55. End up with 6. The next larger square below that is 4. We subtract it. We get 2. Subtract 1 squared because it's the largest square less than 2. Get 1. Do it again. Get 0. So he's got 1, 2, 3, 4, 5. Let capital N be the smallest number for which Jim's sequence has 8 numbers. What is the units digit of n? Now, there might be some cool, when it says units digit, modular arithmetic comes to mind. There probably is some cool modular arithmetic method that I don't even know of. I'm not going to think about because we don't need it really. Maybe you know it and can mention it in the comments. But what we want to think about, let's just kind of get started, right? We're trying to get n to be the smallest number, right? That will create a sequence of 8 numbers. So because of that, let's just try to, instead of thinking about what n is, let's think about the ending. It's going to have to end at 0. And as you can probably guess, you're going to want to subtract the smallest number possible. So if I could subtract 1 squared, that would be great. I would come from 1. And we're just going to work backwards. We're going to place a 1 right here now. Okay, so what is this 1? It's this 1 right here. Right, that's what they transferred to. 2 became 2, 6 became 6. And the sequence is this list on the other side of the equal sign. So again, think about it. If you're subtracting a perfect square, you want it to be as small as possible. That way we can keep n minimized at the end. N being after we get to the 8th number in the sequence. Okay? So I would like to subtract 1 squared again. Because 2 squared is larger, if I subtracted 2 squared, it would necessarily make n larger than what we want. So let's go ahead and subtract 1 squared. What would I put here? It's pretty obvious that it's 2, but if it gets more difficult and it's not obvious, just move the square to the other side, right? It's 1 plus 1 squared after you move it over. That's what this number has to be. Okay, so then we're going to put a 2 here. Notice that this matches theirs. We can kind of piggyback on their ending. But notice they subtracted 2 squared here. Is that ideal for our situation? No, in fact, it's not, because there is still a perfect square we could subtract, and that is 1 squared yet again. You want to subtract the smallest possible perfect square as you go. Move the 1 squared over. This must have been a 3. Again, the 3 becomes the previous number in the sequence. Okay, we've got 4 numbers. We're halfway there. Okay, now what? Can I subtract 1 squared? Answer, no you cannot. The reason is, if you were to subtract 1 squared to get 3, you would have had to do it from 4. But 4 has a perfect square that has access to that is larger than 1 squared. You could have subtracted 2 squared specifically because it says less than or equal to. Okay, well then because of that, we can't just subtract 1 squared. Let's just try the next one up. That seems logical. 2 squared. Then 7 minus 4 is 3. That works because there's no higher square that 7 could have subtracted. So far, this kind of guess and check and feel your way through the problem is working fine. It's not going to work fine much longer. We're going to have to actually think, and that's why at the time in this year, this was a question 25. So let's go back one more step. The 7 transfers here. Now, can I subtract 3 squared? Right? If I try to subtract 2 squared, that won't work, actually, because you would add 4 to get 11. If you were at 11, you would have subtracted 3 squared. So we can't subtract 2 squared. Well, what if we subtracted 3 squared then? Like we said, if we did that, you would have come from 16. 16 minus 9 being 7. The problem is 16 would have subtracted itself. It would have subtracted 4 squared instead of 3 squared. So that's not going to work either. Therefore, this cannot be 3 squared. Let's go back one more then and say 4 squared. 7 plus 16 is 23. That's going to work. This number becomes 23. Okay, we really don't want to go through that process again. You should kind of feel it when you're doing kind of a simplistic process and you get to a point where it kind of gets tedious. That's your sign that you're missing some kind of key idea. Try to see if you can think about it, rack your brain, look through in your mind the different formulas and concepts, and there is a specific one, if you know it, for this problem, trivializes the rest of it. And we're going to cover that right now. I want you to put this in your small notebook. Again, if you don't have a small notebook, watch the How to Study video on my channel. It's in the How to Prepare playlist on my playlist list. There's only like, 10 playlists or something. Find it in there, find the one that says How to Study, and then it will talk about the small notebook and explain its purpose. Rather than just tell you the concept, let's develop the concept. Let's say you have perfect squares. 1 squared, 2 squared, 3 squared, 4 squared. Okay, let's write those down below. 1, 4, 9, 16. Okay, what if I said find the gap between this 1 and 4? It would be 3. Okay, great. How about this gap? 5. How about this gap? 7. Interesting, they're all what? Odd numbers. We're just missing the 1 for positive. Why don't we go back and get it? You could put 0 squared, 0. That has a gap. There we go. There's all the odd numbers. In fact, if you add 1, 3, and 5, you get 9. The sum of the first 3 positive odd integers is 3 squared. We're not going to unwrap all of that part today, but you should investigate it on your own. Please don't mention exactly why that works in the comments. I don't want someone just to get it for free. Think about it. Try to figure out why that's happening. You should know. I've mentioned it in other videos, but maybe you don't, and it's a good exploration to do on your own. So then, where are these numbers coming from, though? What's another way to think about them? Is there any way we could have gotten these numbers from the above values, where we talked about the perfect square part, the base with the exponent? Well, actually, yes. If I took this 1, which is the base of 1 squared, and this 2, and you added them, what is their sum? 3. What if I added 2 and 3? Their sum is 5. 3 and 4, their sum is 7. Is this going to work forever? It absolutely is. Why don't you, on your own, compare x to x plus 1 squared? Compare those two, find their difference, and prove to yourself why it's the sum of their bases. Okay? But I'm not going to do it here in this video. I want you to attempt it on your own. It's actually quite enjoyable to come to that conclusion. So I'll leave it for you to try on your own. What I will tell you is what to write in the small notebook. That is going to be this sentence. The difference in consecutive squares is the sum of their bases. When you are writing concepts in the small notebook, you want to be as succinct as possible. The information does not have to make sense to other people. It has to make sense to you. It's for you to review. You're not writing a textbook for others to understand. It's so that your mind can look at it, recall when you wrote it, and go, I know what that's talking about, right? Because you have a personal memory of the event. So this is what you want to write in there. It's very succinct, it's to the point, and it captures all of the info. But how's it going to help us? Well, if I'm going to subtract 7, right? And I was to compare 3 squared to 4 squared, I already know that the difference in these two is exactly 7. But if I took the smaller one, 3 squared, and I added 7, I would actually end up at 4 squared. But I need to be at a number smaller than the next square, right? And so definitely 16 is not smaller than the square of 4. It's equal to it. That's why we had to subtract 4 squared, the upper number of this comparison. Because the gap between the perfect squares needs to be more than what you need. So now think about it. If we need a gap of 23, and the difference in consecutive squares is the sum of their bases, what two consecutive integers add to 23? Well, you probably said 11 and 12. That's correct. That means if I took 144 and subtracted 121, I would get 23, which means 11 squared is not adequate enough for our next subtraction. We need to subtract the 12 squared. So we will subtract that. Simply move it over here and add it. You're going to add 144 and 23. It gives you 167. Okay, so we must have come from 167 in order to have a gap of 23 between it and the highest square less than it. All right, so now what do we need? We need a 167 here. Let's take stock of where we're at. It's easy to get lost. You could just keep going forever. How many do we have? 1, 2, 3, 4, 5, 6, 7, and we need 8. So we are going to need to find one more number, okay? What about 167? What two consecutive integers add to it? That would be 83 and 84. Okay, so 84 squared will not be enough, or 83 squared would not be enough. We're going to have to subtract 84 squared. So I need to add 84 squared to 167. It's kind of a trivial calculation. There's several ways that you can think about it, but you can in fact use this. For example, if I wanted you to tell me what is 41 squared, you can actually use this concept to calculate it quickly. You would just calculate 40 squared is 1600 and add 40 plus 41. 41 squared would equal 1681, right? Adding 81 to this number, that's what you would get. We can do the same thing to get 84 squared. We just need 85 squared, and then we will subtract 85 plus 84. So 85 squared would be 8 times 9 is 72, 25. There's a trick for 2-digit numbers that end in 5 when you're squaring them. You just take the tens digit, multiply it after that digit in the number line, which is 9. 8 times 9, 72. The 5 on the end means you're going to attach 25. And I think it also works for 3-digit numbers in some way, but it's not quite as clean. I usually don't think about it for that. How often are you squaring like 235 squared, right? Just do it by hand at that point. But it might work. I don't even know. I don't never use it though, so I am not quite sure. So 85 squared is 7225. You can simply subtract 85, right? And then that would give you what? 7140? Okay, and then subtract 84 from that. I'm going to subtract 40 to go down to 7100. And then if I subtract, 7100, and then I need to go 44 more. So it would be 7056. So 7056 would be here. Wait, I have to subtract 84 squared. Yeah, I need to, hold on, how does that work? I actually need to use, 84 squared. So 7056 is 84 squared. Well, I just needed the number to add it. That's what it was. Add 7056 to this. My bad. So if I add, actually, we could have just taken the, if I would have thought about it, the 85 squared and taken away 2, it's 7223. Correct? Let's just think about that. The gap between 84 squared and 85 squared is 169, right? And then I just needed to take away add 167 to the starting number. It makes sense that you would only need to subtract 2. One more time, I just want to clean that up really fast. This is the number. The answer is going to be 3b. But just to clean it up really fast at the end, what I was trying to say, if you were at 84 squared, you know that the gap between 84 squared and 85 squared is 169. But what you want to do is take 84 squared and add 167, which is 2 less than that gap. So if I was thinking on my toes, I would have just said 7225 minus 2. The gap between here would then work. I will see you guys in the next video. I hope you have a good one.